Hey everyone, this is Steven, StoicDev0 on Twitter. I am a Solidity dev at Remark, co-author of the EVM implementation of the protocol, together with 3 merged AIPs. This is part of the first project series, where I teach you how I built Snake Soldiers. Remember, this is a personal project, it just happens to use Remark. In the previous 6 videos, we created a fully functional and customized contract for our main character, the Snake Soldier. In this video and the next 2, we will be creating custom contracts for our 3 types of gems. The first one we'll see is the skill gem. On the process, we will learn the advantage of abstract contracts, how we can use getAsset metadata to reuse an asset for all NFTs, and how to create claimable NFTs. Let's start with the abstract contract. We will have 3 gem types and each needs its own contract, but most of the functionality will be very similar. To follow the drive principle, don't repeat yourself, we can put all the shared logic into an abstract contract and have the others inherit from it. The idea is that each token owner of the Snake Soldiers will be able to claim each of the 3 gems, 1 for Snake. So let's start with some imports and a couple of error definitions in case the token owner already claimed the gem and in case he's trying to claim a gem for a token he doesn't own. Now let's define our abstract contract. This keyword here makes it abstract, so that means it doesn't have to be a full implementation. It will be very clear by the end of the video what this means. We will call them base gem and just inherit all these building blocks we already know. I'll need a variable to store what the address of the Snake Soldiers contract is, a mapping from token ID to whether it was claimed or not. Again, I'm using an int. I could use a bool, but I found it's usually cheaper this way. I'll store the token URI. This will be the same for every token, so it's a fallback for legacy collections or legacy marketplaces. Total supply, total assets, max supplies, this is all things we already used in the previous contract. I will define also a constant for the main asset ID because I plan to do the same trick of adding the initial asset on mint, and I will define the offset for soldiers. This will make more sense when we are customizing the getAsset metadata function. Next we have our constructor. We will receive the name and symbol of the collection. This will vary according to the gem. Collection metadata and token URI will also vary according to the gem. The Snake Soldiers will be the same for each instance of the contract, and the max supply too, which will be just the same as the max supply for the soldiers. We initialize each of these contracts, passing the name and symbol. Again, I'm fixing the royalty to 5% here, and I'm setting the royalty receiver to initially be the sender, so whoever deploys this contract. I stored these 3 variables, the rest are taken care of by these constructors. The next thing I want to add is some utility getters. So for total supply and max supply, token URI, so it's compatible with older collections, and Snake Soldiers, so I can easily check what the address is and make sure it was right. Then I will add the methods we also added to our Snake Soldiers, to add an asset entry, an equipable asset entry, and finally we also want to be able to add assets to tokens, right? Another important thing we learned in the earlier videos was that we need a way to set a valid parent according to the equipable group. We will also need a way to update the royalties, so this can correctly inherit the royalties extension. In this case, we will not get an error because this is an abstract contract, so we don't have to define everything that's left here, but we will have the same implementations on all of the gems, so we can just add it here already. I'll also add a method to withdraw whatever we raised. Although this contract is not meant to receive anything, at least by the mint, I will leave it here just in case someone sends some native token by mistake to the contract. I check that it was not already claimed and I mark it as claimed, so next time it won't be able to do it. I increase the supply, and I want to make sure that the guy who is doing the call, or the address that's doing the call for this Snake token ID, is actually the owner of that token ID. So I will do that using the nestable interface, and I will make sure that the owner of this snake is actually the caller. Otherwise I will revert. After all these checks, I will mint a new gem into the Snake Soldiers contract. This is the gem ID, which will be the same. This is the destination ID, so the snake that is receiving the token, and this is just some empty data. Then we will do the same as we did for the Snake Soldiers. We add an asset, the main one, and we directly accept it. I created this as an internal function because I want it to be called individually and for many tokens. So in case there is an owner with many snakes, you can just do a single call. I also want to have a way to check if the gem for a specific snake has been claimed, so I would just add this getter. The next interesting thing I want to do is to define a customized getAsset metadata. If you remember, this receives the token ID and the asset ID, so we can customize it according to the token. The first thing I will do is to get the base metadata URI from the original implementation of this, and then there is something I will call post URI. This is what I will append at the end, and it will depend exclusively on the token ID. I will just return the concat of them, and then I need to define this function. Actually, this should be string.concat. Now this is the beautiful thing of abstract contracts. I can define a function here, which I'm already using, but not actually implement it. The final contracts will have to actually override and implement this in order to compile. And that's all we're gonna need on the base gem contract. Now let's go to our skill gem contract. We'll inherit base gem, and the constructor will simply define a couple of things here. The name and the symbol are fixed, the rest we pass it. Next, I will add some constants. This is what I will be appending at the end of the metadata asset URI according to the token ID, or better yet, according to the type of gem that it got. The only thing pending is the post URI implementation for this specific gem. I didn't mention this earlier, but we don't want the same groups of gems always together, so we will assign this with 3 different strategies for each gem. For elements, we will use round robin with 4 options, as we did for the X. For factions, we will do the same but with 5 options. For skills, we will also do round robin but repeating the same type before moving to the next. We can achieve that with a bit of math. There's a catch. We want generals and commanders to always receive a gem that matches their element, at least for skills, since the right combination of gems will boost your abilities in battle. So let's see the implementation. We receive the token ID, and for soldiers, that is, if the token ID is after the soldier's offset, we will use this operation. This will result into this sequence of numbers. You see, each of them is repeated 2 times before starting over. For generals or commanders, we will just do the same operation that we did to assign the elements to the X. Now, if the result was 0, we will assign a combat type. For 1, tanks, for 2, heal, and for 4, sniper. We compile and see that our skill gem fits nicely, and that's it for the video. On the next one, we will create the contract for our element gem, which will be forever soulbound to the snake.